Hello, Keith Rucker here at VintageMachinery.org. Guys, today got a little project we're working on, helping out a fellow YouTuber and a friend, Eric, over at Hand Tool Rescue, contacted me a while back, and he is in the process of restoring a little steam engine that he picked up and was needing some help. Now, if you're not familiar with Eric's YouTube channel, I would encourage you to go check out Hand Tool Rescue. He does all kinds of restoration projects, kind of does time-lapse videos showing the process from start to finish, and does an absolutely amazing job of doing restoration work. I have met up with Eric a couple of different times at some different events over the years, and consider him a friend, and we kind of chat back and forth with one another fairly regularly. And he reached out to me when this steam engine project came up because he had a part that was missing some parts and wanted to know if I could help him out. And the part in question is a crosshead that goes in there that was missing the brass shoes that go on it that actually help it go up and down in that steam engine. Let me zoom you in here, kind of show you what we got, show you the challenges, talk about how we're went around getting some parts made to make these parts, and we're going to be finishing that out and doing the machining work in this video, and probably going to be a couple of videos to get this project knocked out. Let's let you take a look at it. So this is the casting that Eric sent me, which there's absolutely nothing wrong with this, but it's missing the parts that go on it. So if you look, we have a tapered piece on either end. There's a milled flat in here, a milled slot, I guess you could say. The male part that goes into a slot. But what is missing is there's some brass shoes that go on here. Now, if you're not familiar with a crosshead, this is a very common item on a steam engine. You would have a crankshaft with a piston rod that came up into this. There would be a pin in here that would allow that piston rod to go back and forth as it's rotating around. And then this would go up and down in a guide, and that would basically translate the rocking motion of the piston rod down here to a linear motion above it where it's going up and down, and you'd have another piston rod that comes out of this that the actual piston would be attached to inside the bore on the steam engine. So its whole purpose is to, again, take that rocking motion this in the piston rod on the crank and make it a linear motion going up to it. Now, when Eric got the steam engine, the brass shoes that were on this were missing. He reached out to me and said, "Hey, can you help me with this?" And I said, "Well, I can kind of envision what was there, but didn't know exactly how the originals were." Fortunately, Eric reached out to one of his YouTube viewers who had the same engine, and he sent along some photographs of the way it works and the way it looks. And this is what we're basically basing our work off of. So if you look here, there's the crankshaft down below. That's your piston rod that comes up to it. It goes into that crank pin that rotates back and forth. Notice on either side we have in the casting a channel that goes up and down. In this case, it's a circular. I forget the diameter. I've got it written down someplace else, but it's a circular section, and it goes up and down in those guides. And you have these little brass shoes on either side. And they're kind of a wedge-shaped shoe. There's a little tab on the top where you can put a bolt in there and adjust them. The reason that they have the taper in there is it's self-adjusting. Well, not self-adjusting, but adjustable. So as the brass wears in these shoes, you can just tighten that up. That moves it down. When it does, you have the wedges that are going against one another, and it widens it out. So you can adjust this on the fly as wear happens, and just keep your engine up and running in good shape. So knowing what they looked like, we were able to kind of figure out what we needed. He sent along a couple of other pictures here, just some different shots. Here's a little bit of an angle there. Again, you can see the screws in there where they adjust up and down. Here's a shot kind of from the top. But using these photographs and having the casting here, I was able to come in here and basically measure the original casting, measure what was in the drawing, come up with a ratio, and basically be able to calculate some dimensions off of this, at least get a rough idea of what those dimensions were. From there, I drew this part up in some 3D modeling software. I used Fusion 360 and basically turned that into a pattern. So there is what I drew up of that shoe. Again, we have that tapered piece on this side. We got the radius on the other side. Got the little piece up here for the screw to go in. I made it a split pattern, so we cut it in half. You see the holes here. This would be where some dowel pins would align the top and bottom halves of those. And I sent this off to my buddy Clark over at Windy Hill Foundry, and he was able to take my patterns. I 3D printed the patterns, by the way. He took my patterns and was able to cast some castings to make the shoes out of. And here they are. So these are what we got back from Clark. Again, we have a flat surface here. We're going to machine that slot in there, but we got the little tab up on top. And we will, of course, have to machine the outside diameter of this to the right diameter. They're oversized, so we should have plenty of metal to be able to remove off of them and make everything work out. So this is what we got to work with, and the job for today is to at least start the process of machining these. First thing I want to do is set these up in the mill machine. We'll machine this top surface flat, get that rough casting off of it, just clean it up, and then we will cut a 1-inch wide slot in this that will allow that to sit up on this and adjust up and down like such to tighten and loosen it. Once we get that part done, of course, we'll have to get our holes drilled in the top for the adjustments, and we will mount these shoes on either side of this, and we're going to have to make a fixture to mount this whole thing in the lathe, and we will turn the outside diameter to the correct diameter and everything else mounted to this so that it will all be concentric and be just right. So that's kind of the game plan. Let's go do some machining. All right, so we're going to set up over here on my vertical milling machine to deck off the top of that flat surface there and cut that slot in here. And the setup's going to be a little bit on the tricky side, not too bad. I'm just going to grip it in my vise kind of like such. But here's the challenge. This surface right here is really kind of the reference surface that this whole thing is going to be built around. And we've got some taper built into that and everything else, at least in the pattern we did. We want to make sure that don't have this thing all cocked in here at a weird angle. So to mount this in here, this is my game plan. You know, we're not looking for any kind of total perfection here. This is a rough casting, but we do need to kind of get it close. So I've got some parallels. The depth of that slot is about 200 thousandths. So we're going to have to deck a little bit off the top of this. So I need to get this up off the vise. I'm going to just do 250 thousandths. I think we can get it cleaned up and everything with that. So I've got some parallels here. These parallels, when they stack two of them together, that's 250 thousandths. And I know that the tops of my jaws are nice and parallel to one another. So we're just going to kind of use that as a reference to kind of get this thing roughly to the right depth. And again, it doesn't have to be perfect because it is a rough casting. We're going to be machining. This will become our reference surface. I'm also going to take another parallel here and just kind of put across that, and let's just kind of cut it flush right across the top. And now I've got it positioned where I should be able to do all my machining. And I'm going to get this good and tight over here in the vise. And let's get an end mill or something on here to face that off, and we'll get started milling this thing out. All right, I got a face mill on here. I'm just going to drop this down until it's just barely touching there. We'll come off, and let's see how fast we're going here. That'll be fine. And let's just I'm just going to go across it without doing any down feed on this first pass. Since that is a rough cast, and I'm sure it's going to touch in a few places. I just want to clean this part up. So I'm just going to do about 10 thousandths up feed. Let's do some light passes here and get it cleaned up. We'll feed across there. All right, I think we are good. Let's pull that back around there where you guys can take a look at it. So I just took about 10 thousandths. Really, it cleaned up pretty easily. Yes, we got a little bit in the middle that didn't clean up, but remember, we're going to cut a slot through there, so all that will get cleaned up when we do that. Really, the only parts that's going to be left of this are the two edges, so that's all going to get milled out. All right, let me do some figuring here and get set up to cut that slot in there. All right, next thing I want to do is find the center of this part, roughly the center part. Again, it's a rough casting, so it's not going to be perfect. I've got an edge finder on here. We're going to find the edge. We'll zero my digital readout, come find the other edge, and then using whatever measurement that is, take half of it, and that'll get me in the center of this part, or at least very, very close to it. Again, because this is a rough casting on the sides, it's probably not going to be perfectly in the middle, but it gives us that reference that we're going to create that will make that the center, and then we'll clean it up later. Actually, there's no need to, but we could clean it up later so that it was the same width on either side. Let's come in here using our edge finder. We'll go over until that just pops over right there. I'll zero out my digital readout and just verify here. Yep, we're good. All right, go to the other side. Come in on it. Again, same thing. Just ease that table in until it jumps over right there. And I just halved that measurement, and I'll dial my table into 0, which is right there. All right, again, there's the crosshead that we are going to be making a slot for. So this needs to be down. It's 1 inch wide, and it's actually, I think I said 200 thousandths deep. It's 150 thousandths deep is how deep that trough needs to go. I just took a Sharpie and put some rough pencil marks or pen marks on there. That is not a precision mark by any means, but it just kind of helps me make sure while I'm doing this that I'm not about to screw something up. And what I'm going to do here is, this is a 1/2 inch end mill. Again, our width needs to be 1 inch, which means that if I make a slot all the way down the center, I'm going to have to go over 1/4 of an inch on either side. 1/4 of an inch plus 1/4 of an inch is 1/2 inch, plus 1/2 inch is 1 inch. So that's my reasoning there, and that will get me down or to the right width. Now, what I'm going to do is I'm going to probably just, instead of going 250 thou, I'm going to go 240 thou, which will leave about 10 thousandths on either side to clean up at the very end. And I can, once I get the final depth, I'll get my edges nice and one cut. So I'm going to leave a little bit of material in there to the end. All right, let's get her done here. We'll fire up our machine. I'm just going to raise my table up here until I see a chip. All right, we're into it there. I'm going to back off just a little bit. I'm going to re-zero that out. Right there. That's going to be close. All right. I'm going to try to do some light cuts, I think, here. I'm just concerned, my work holding's not the greatest in the world, so I really don't want to be making super aggressive cuts. So let's just go up. Let's just go up 25 thou, which is right there. And just cut right across that. I'm going to bring my table over towards me right here in this direction, 25 thou, or 250 thou rather, 240 thou. We want to be a little shy. And we'll come down that back side there. And now we'll go to the other side to 25 thousandths past center, or 250 thou again rather, 240, and come back down. So here we go. We're just going to continue on. I'm going to raise my table up to 50 thou, and which will be 25 thou more. It's going to eat it away. And right here, I'm going to take us a moment, and I want to get a depth micrometer, check this depth, and so we can dial in the right much for that last pass. Let me go get a depth micrometer. All right, first thing I want to do is make sure I don't have a burr or anything on that edge, and I don't. Feels good. And according to my digital readout, we're at 125, let's say 126 thousandths. We're right there at it. I'm going to put my, let's see, back that off a little bit. Put my depth micrometer in there. And let's come down and measure that depth. And it looks like we are right at 130 thousandths deep. So I'm just going to change this on my digital readout from 125 or 0.8 to 130. So we'll just 0.130, enter. All right. So that will make sure we're at the right depth. I want to go to 150 thousandths, so we got 20 more thou to come out of there. And while we're at it, let's just let's measure this. I don't really have a super good, we're about 10 thousandths undersized, so that's good. All right, let's do our final pass here. Come across 240 again. And I need about 5 more thou on each side, so we're going to go to 245 and come back down each side. How about that? 245. We'll come down this side. I'm just cleaning up the edge now. The depth is the same. We're just taking about 5 thou off all the way down. All right, I'm just going to get a good measurement across that again. And we need to go do the same thing on the other side, 245. Clean that side up. maybe a thou under, but the part is about 5 thou under, so I think it's going to be just fine. Yes, that's going to be perfect. All right, I think we've got this one machined out for the back side. I'm just going to go ahead and take her on out of the vise, and we'll do the other one. Well, I got my second one milled off camera, but you can see here we got our finished parts, and everything appears to be working on here just like it ought to. This is kind of the way that these will go. They will mount on there. We've still got to drill the holes through here for the screw to adjust it up and down. But the next step I want to do here is there is a screw on each one side of these that fits into right here, and there's a little slot in the casting here that captures that allows that to move up and down. But what this does is it holds that bottom in. It keeps it in there nice and tight. Now, I don't know what kind of screw they originally used. I got these little button hex head screws, and that's what I am going to use. It's tapped 1/4 20. That's what was originally in the casting. So what I want to do is transfer these holes from there over to the casting so that I know where that hole goes, and then we will drill a slot, and then we're also going to drill a little bit larger slot for that head to fit down into so that it can move back and forth. So that's going to be up next. Let's get her done. So to start out with, I just took my Sharpie and I marked the sides A and B. Once we start drilling these holes in here, I don't think that they're going to be able to swap from one side to the other. The holes are not, neither this hole on the side nor the hole on the top appear to be in an exact position. They're just kind of wherever they ended up at. So I just marked those, that way we can keep them separate. Now to transfer this hole, what I'm going to do is use a set of transfer screws, and I've already confirmed that hole is 1/4 20, 1/4 inch, 20 threads per inch. So I got my little 1/4 20 transfer screw here. What this is kind of like a set screw, but it has a center punch in the very center. You use the tool to insert it just like such. There's a little hex ground on the end, and you can see it's like a little center punch. And what we'll do there is put that one in there and make sure I got A and A, and I want that to be kind of right at the bottom. And I'll just take a hammer, pop it, and I've got a center hole punch there. And we'll do the same thing on the other side. Let me pull this one out. We'll flip it over, put the transfer screw in this side. And same thing, this is piece B. It's on the B side. And we have our center punch hole. All right. I've got my parts set back over here at the milling machine, and as you can see, that hole is nowhere near the center, but that is where it's at, and that's where it needs to be at. I have a center punch just kind of chucked up in my chuck, and what I have done is I have lined it up directly over that hole, and we're going to take our center punch out, put a 1/4 inch drill bit in here, and drill a hole all the way through the part, and then we'll come back and slot it with the milling cutter. So let's go ahead and drill that hole first. All right, I got a 1/4 inch end mill in there. Start it up, and I'm just gonna raise the table up. We're gonna go right down that hole we've already drilled. And let me peek over here. Need to go all the way down until we come out the other side. And we are out now. And I'm just going to zero out my digital readout, and I'm going to go 50 thousandths in each direction to just give me a little bit of a slot in there. Don't need a whole lot. Well, we may do 75 thousandths. Give us a little bit more room. That's 50, 60, 75 right there. And we'll come back the other direction, do the same thing. 75. All right. All right, so up next, what we need to do is we need to make a slot for this head to actually drop down below the surface. Now, I've done some measuring and calculating, and what I want is I want to have about 100 thousandths of area in the bottom of the slot that's still 1/4 inch, and I measured the head. We're going to use a 1/2 inch end mill, which is just a little bit larger than that head, to give us room for a slot. Now, to measure that, what I'm going to do is I got some parallels here, and I'm going to just drop that all the way down till it's touching the parallel, and I'm going to zero out my digital readout. And I know that this piece here is 150 thousandths deep. I want another 100 thousandths, so I need to basically raise my cutter up 1/4 inch or 250 thousandths. So I'm going to do just that. I'll just watch it on my digital readout. We'll drop the table down until we get to 250, which is about right there. I'll lock my table. And now that's where I need to be at. Okay, but we've got to drop it down farther so that I can get my part up underneath there. But I'm going to zero out at 250 thousandths, and I'm just going to crank my table down. We'll slide our part up underneath it. I'm just eyeballing this. I've got a little bit of extra room in there on my width, so if it's not perfect, it still we should be fine. But we'll just get that centered up like such. I think that's centered right there. I'm just gonna clamp it down, and I didn't move my table. Even though I flipped it over, we're still lined up in this direction. That's right on zero. So now what do? We're just going to raise the table up until we go back to zero on the digital readout. That should be my proper depth, and we'll move it back and forth 75 thou, just like we did before. All right, here we go. Coming up. Right here. Touched off. I'm just gonna eyeball that. Yeah, I think we're centered up really good. All right, I'm just gonna watch my digital readout and go down until it gets to zero. We got about 125 thou to go. 100 thou to go. 210 right there. And now we'll go in and out 75 thou, just like we did before. There we go. That should do it. All right, let's see how we did. There's our slot. Screw hole goes to the bottom. Our 1/4 screw fits through there. We got a little bit of a slot in there, which is just what we want. And let's put it on there and see how it does. All right, we're almost bottomed out there. I got a little bit of room, and we got some adjustment in there. That's just what we want. We might want to make that slot a little bit longer. I I may adjust that off camera, but I think we are in good place here to be, and we will get our other side put on here as well. So guys, there's our finished slot, and I will just say that once I brought this over here, I realized my slot wasn't quite long enough, at least in the up direction. The bottom going down, it was fine, but I needed some more travel going in that direction. So I set it back up and made it a little bit longer. Same basic principle, but there's our slot. Our button head screw fits right down in there, slides back and forth, and now we can tighten that up, and we've got nice travel up and down. We can lock this in place wherever we need to, and that will just help hold that in place on the steam engine, and we can adjust the height of it using the screws and stuff up top. And again, that just makes this a variable width with these bevels in here. So anyway, moving right along, I'll do the other one off camera, and we'll be getting even closer to being done with this. So off camera, I got the slots cut in the second piece. Everything's been test fit, everything looks good. The next step here we need to do is drill the hole, the clearance hole in the top of this. That will allow that screw to go through there to adjust this up and down. And to do that, what I'm going to do is again use these transfer screws. So these are 5/16 18. We'll just drive those right in there to the proper depth. These can stick a little proud, it'll be fine. I got 2 of these, we'll do one on each side. Make sure I got B here. We'll put that in the slot, slide it down, take this over to the edge of the table where this can slide up and down and drop off the edge here. We'll take our hammer and tap it, and we got a nice center punch hole there. Flip this around, grab the A part, do the same thing here. There we go. All right, here we go. Now go to the full size. That moved just a little bit. We move it back. There we go. I think we got them both drilled. Let's go test them out and see how they work. All right, we're moving along here. I think I've got my clearance issue taken care of, but I've ran into another little problem, and that is the top of these pieces here, they had draft in them, plus because of the angles that we're on, these are not parallel to the bottom of this cap screw. When I'm tightening it up, it's hitting on one side before the other, and it's causing it to kind of want to push the part away from it. So I think what I'm going to do is take this whole setup over to the milling machine and just kind of deck the top of this where it's flat all the way across, and I think that'll really kind of help us out. So let's go set up and do that real quick. I just got this set down in the vise. It's clamped in there. Our set screws are not set screws, but those screws are attached in the bottom. To kind of squeeze this in tight, I just put some vice grips across the top here to make sure we got it held in tight, nice and snug on there. And I just want to cut these where they're parallel to the world here. So let's, and we'll just drop down to that level right there. Take a light pass across here. about another 5 thou. Raise my part up here. We'll go to the other side. And with that, I think that we have our shoes mounted to the crosshead. And the next step will be to turn this diameter to the correct diameter on the lathe. Like I said, we're going to have to make a couple of fixtures to do that, to hold it on the lathe. And that's going to be a separate video. But I'm real happy that we got this project this far along. Here's our slots for our screws in there. That's not going to hurt anything as far as the bearing surface goes. Not a problem at all. And got the adjustment in there. We will machine it with them all the way up so that over time you can pull a washer out and tighten these up one side at a time to take out adjustment if necessary down the road. There we go. There we go. Got that part of the project knocked out. Real happy with that. I think Eric will be very happy with the results as well. And looking forward to part 2 here and getting this thing set up over on the lathe so that we can finish it up. Guys, that will be a wrap. As always, thanks for watching. Please subscribe to my channel if you haven't already. Thumbs up and comments are appreciated. And we'll catch you on the next video. Thanks for watching.